All right, let's dive straight into this explainer. For generations, whenever we looked up at the night sky, we saw this glowing rock that pretty much everyone universally accepted as bone dry, barren, and frankly, totally lifeless. But, space exploration is really all about challenging what we think we know. And the story of how the Indian Space Research Organization, ISRO, completely flipped our understanding of the moon, it's nothing short of mind-blowing. So settle in because we're about to unpack a cosmic detective story that literally changed the trajectory of human spaceflight forever.
So let's kick things off with a massive cosmic mystery. Have you ever actually stopped to think about how celestial body we've always considered dead could possibly be hiding water? It feels like a total paradox, right? For the longest time, scientists believed finding water up there was basically impossible. I mean, without an atmosphere, any liquid water would just instantly vaporize and get sucked right out into the vacuum of space. But as we're going to see, the universe definitely loves to keep us guessing. To really grasp the challenge here, you have to understand just how brutal the lunar environment is. During a lunar day, temperatures skyrocket to a literal boiling point, 125 degrees Celsius. That kind of daytime heat would vaporize liquid water in an instant. But then, during the lunar night, the temperature absolutely plummets to a freezing minus 173 degrees. Sustaining water in an environment that violently swings between a boiling oven and a deep freeze, it honestly seems mathematically impossible. But nature loves a loophole. Back in the 1960s, some scientists started suspecting that these incredibly cold, permanently dark craters could act as ancient deep freezers for ice. They called them permanently shadowed regions. We're talking about incredibly deep craters right at the moon's south pole, where because of the angle of the sun, light never ever reaches the bottom. Down there, the temperature sits at an unbelievable minus 250 degrees Celsius. That is practically absolute zero. In a freeze like that, water ice wouldn't just survive. It could remain perfectly preserved for billions of years. Section 1. The breakthrough discovery. And that brings us perfectly to the historic breakthrough that completely upended the scientific world. From those early suspicions back in the 60s, it was a really long wait until 2008. The mystery just sat there, totally untested, until India finally stepped onto the world stage with its very first lunar mission. It really set off a chain reaction that sparked this whole modern era of space exploration we're in today. Then October 2nd, 2008 hits, and history is made. India's Chandrayaan-1 mission deployed a device called the Moon Impact Probe. Now, this wasn't some gentle, delicate soft landing. It was an intentional, high-speed crash. As this sensor plummeted toward the surface, it rapidly beamed back data. And literally right before impact, it detected undeniable signs of water molecules. For the first time ever, a space mission proved that water actually exists on the moon. The entire scientific community was just absolutely stunned. And they didn't just find, a few drops of frost. Chandrayaan-1 picked up signs of water ice in roughly 40 small craters. When researchers actually sat down and crunched the numbers, the estimates were jaw-dropping. We are talking about a staggering 1.3 trillion pounds of ice hidden across the lunar surface. It completely, utterly changed how we view the moon's potential resources. And this wasn't just a fluke. The massive scale of ISRO's discovery was quickly backed up by international peers. Fast forward to 2013, and NASA's Lunar Reconnaissance Orbiter, the LRO, turned its instruments toward the Shackleton crater down at the South Pole. What did they find? A massive 22% of that crater's surface was covered in ice. NASA's data perfectly validated ISRO's groundbreaking discovery. Okay, so here's the next logical question that's probably bouncing around your head right now. If the moon doesn't have an atmosphere, and we all thought it was bone dry, how on Earth, or rather, how on the moon, did 1.3 trillion pounds of ice get there in the first place? While the going theory is that over millions and millions of years, comets and asteroids basically acted as ancient cosmic delivery trucks. Remember, comets are essentially giant chunks of dirty ice. As they violently crashed into the moon, the ice they carried was blasted into those permanently shadowed regions. Shielded from the burning sun, the ice just got trapped in those deep craters and stayed there, perfectly frozen in time. Section 2. Heartbreak and triumph at the South Pole. Because, knowing the ice is there is one thing. Actually getting a spacecraft down safely to touch it is an entirely different beast. Enter Chandrayaan-2 in 2019. This was ISRO's most ambitious swing yet. They built the lander entirely in-house. Now, The orbiter part of the mission was a massive success, and it's still sending back crucial data today. But on December 7th, 2019, the whole world watched in heartbreak. Communications failed, and the Vikram lander crashed just 2.1 kilometers above the surface, taking the Pragyan rover with it. It was a brutally tough day for scientists and space fans everywhere. But space exploration is practically defined by resilience, right? Redemption came in 2023. ISRO took every single hard lesson from that crash and poured it into Chandrayaan 3. And on August 23rd, the world watched again, but this time pure celebration. Chandrayaan 3 spectacularly stuck the landing. India made history, becoming the absolute first country in the world to successfully soft land on the incredibly treacherous, heavily cratered lunar South Pole. And the Pragyan rover, it didn't waste a single second. It rolled right out onto the surface and immediately got to work analyzing the soil. And it found an absolute treasure trove. Right there at the South Pole, Pragyan detected sulfur, aluminum, calcium, and iron. We aren't just talking about cool moon rocks here. These are the fundamental, essential building blocks for future construction and survival off-world. Section 3, Building the Future. So putting it all together, what do these elements, and especially the water, actually mean for the future of humanity? It leads us directly to the million-dollar question. Why is every major space agency on the planet suddenly in this massive race to build lunar bases? Why is everyone looking at the moon not just as a quick tourist stop, but as a permanent place to live? It literally all boils down to that ice. If we can harvest it, an actual sequence for survival becomes possible. Step 1, melt it into drinkable water for the astronauts. Step 2, use that water to grow crops in lunar greenhouses. And then there is the absolute game changer in Step 3. This is the real reason the space race is back on. The ultimate goal is chemistry. By using electricity to split those lunar water molecules apart, scientists can extract hydrogen and oxygen. And what happens when you combine hydrogen and oxygen? You get rocket fuel. By processing this water, we can manufacture fuel directly on the moon, turning the surface into an interplanetary gas station. This totally flips the math on deep space exploration. Escaping Earth's massive gravity with a heavy rocket is ridiculously expensive. But the moon's gravity? It's just a fraction of ours. Launching deep space missions, like, say, a human mission to Mars, from the moon instead of Earth, will save an astronomical amount of money and resources. The moon is literally our stepping stone to the rest of the solar system. And speaking of saving money, we absolutely have to talk about ISRO's greatest superpower, their incredible low-cost efficiency. While space exploration usually burns through billions of dollars, ISRO executed the incredibly complex Chandrayaan 2 mission for roughly 980 crore rupees. That's just over 100 million US dollars. It is a tiny, tiny fraction of what Western space agencies spend. ISRO consistently proves you can do cutting-edge, historic science on a remarkably lean budget. Ultimately, by taking that bold risk back in 2008 and leading the global charge in discovering lunar water, India helped completely reframe our relationship with space. The moon is no longer just a glowing rock in the night sky. It's the first step for future human civilization. It is the outpost that's going to allow us to push deeper into the cosmos than we ever thought possible. Which brings us to the end of our explainer today, but I want to leave you with a provocative thought to chew on next time you look up at the night sky. Given the incredible, rapid pace of these discoveries, do you think humans will build a permanent, functioning city on the moon in the next 50 years? I mean, we found the water, we've successfully touched the South Pole, the building block elements are sitting right there waiting for us. The countdown to a lunar civilization might have already started. Thanks so much for hanging out with me for this explainer, and as always, keep your eyes on the stars.